Power is another concept related to work and energy. So we've talked about how work can be a change in energy, and you get it from a force that's being applied over some displacement. Power is basically how rapidly that's happening. Power is work over time. The units are going to be joules per second, since work has units of joules and time of seconds, and we define that as a watt. Okay? Be careful, because this W here represents work, and it's in another equation. This W stands for the watt, and it's just a unit. Okay? So let's look at an example of how you would apply this. So if I had a 20-watt bulb connected to a battery storing 10,000 joules of energy, how long will the light bulb stay lit? So in this case, we want time, right? So we're going to solve for T. So T is equal to work over power. What's the work that's being done here? Well, it's going to stop being lit when the battery runs out of energy. So it's going to go from 10,000 joules of energy to 0. So our change in energy is our work, and is 10,000 joules. So we'll put that in for work. The power, we're told the bulb is a 20-watt bulb. So the power is equal to 20 watts. So now we can divide 10,000 by 20 and get 500. And a joule over a watt, well, a watt is a joule per second, so the joules cancel, we get seconds. So we get 500 seconds is how long that bulb would stay lit. Good. Pretty straightforward application of how you might use power. Let's look at an example that's a little bit more challenging. Suppose, 10,000 joules of energy. Now let's suppose that the bulb radiates photons, which are just particles of light, with average energy equal to 10 to the negative 19 joules. So really tiny. And I want to know how many photons are radiated in 5 seconds. So this one's a little bit trickier, but still very doable. So in this case, we want to know, if we know each photon has some number of joules of energy and they're going out, and we want to know how many in 5 seconds. We need to know how much energy in total is radiated in 5 seconds. So what's going to be the change in energy, right? Work is going to be time times power. So work equals P times T, where our power is our 20-watt bulb, and our time is 5 seconds. So we're going to have 100 joules being radiated in 5 seconds. So then what do you do with the 10 to the negative 19? Well, we know we have to do something. We have to divide one by the other, because this shouldn't have units, right? The number of photons should be either unitless, or you're going to keep units of photons. Well, if this was average energy was 50 joules, you'd say, oh, well, I have 100 joules of energy, 50 joules per photon. That means I must have 2 photons. It's just harder to see it because this number is weird. So in this case, in the case where we had 50 joules, we did 100 divided by 50 is 2, so we do 100 divided by 10 to the negative 19. So we have 100 joules. We divide by 10 to the negative 19 joules per photon, and we get 10 to the 21st joules, 10 to the 21st photons. That's how many photons are put out in 5 seconds in this scenario, which is quite a photons. So this is pretty much it. This is as far as we're really going to go with power in this course, and you should be able to do problems like this and apply it as such. You may sometimes be required to say, oh, well, looking at the video where we did work is equal to force times distance, and maybe you'll put in force times distance here and divide it by time to find something there. But in general, it's not going to get a whole lot more difficult than that.